So we start our discussion. This is actually, I want to say it's chapter 11 in your book. I didn't tell you that, but I think it's chapter 11. I think it's 11.1. But what we're talking about is sequences, okay? And we're going to talk about series later on, which is really just the addition of of a sequence. But the first thing we started with was, you have some sequence of numbers, and what we're doing right now is finding what we call the general term. So to more formalize what I mean by general term, I need an expression that if I plug in n equals 1, I get 2. If I plug in n equals 2, I get 5. N equals 3, I get 8. And so forth and so on. Okay? And so the expression that we're going to use there is for this, where you're just simply adding 3 every single time, every time you have addition of 3, that ultimately when you add 3 a bunch of times, that becomes 3n. That's like multiplying, it's adding 3 5 times is 5 times 3. So what we're going to do is, this one's going to be 3n, and then the way I do it is I start with 3n and I say, okay, well, we got to get to this piece in front of it. What number comes in front of it? Well, if you added 3 to it, it would be minus 1. Okay? Now, I think the way some people learned it is they learned it as a to the n equals 3n minus 1 plus a1, I think, something like that. Is that right? Well, yeah, times d. 3d minus 1, though, right?
Oh, no, it's plus a1 here.
Yeah, but the only difference is the n in this case is a d for you, yes?
Yeah.
The ironic part is if you do this, what do you get? 3d minus 3 plus 2. You're basically taking the first thing and bringing off the difference. Okay? I just don't formalize it into a formal formula. I just say find the common difference and then go back and find whatever that number was, would it be in front of it. But it's the exact same concept. So that's what we call a arithmetic sequence. Now, the one that we're discussing right now is called a geometric sequence. And a geometric sequence means we're not adding the same thing over and over again. We are now multiplying the same thing over and over and over again. Okay? So the numbers that we have are 2, 6, 18, 54. What would the next number be, just out of curiosity? It would be 162, right? Which would be 54 times 3 is 162, and then the next one would be 486. Then the next one would be 1,358. I'll trust you. Reluctantly. And then the next one would be, just don't even worry about it. Just be like minus 5 would be the next one. I'm not doing it. How do I write the general term for that? How do I write the general term for that? Anybody got a thought? Go ahead.
This is like a formula that I used last year. But it was just an equals a times r to the n minus 1 power.
Okay. How do you get to that formula? Do you know?
No, but I know I have used it.
Okay. So the formula that some people will proclaim to remembering would be a to the n equals a1 r to the n minus 1. Okay. Now, what is R? I don't need. What is R? R is the ratio. So R is basically the ratio between any two consecutive numbers. That'll tell you what you're multiplying by. Okay? So in order to get from here to here, you got to multiply by 3, multiply by 3, multiply by 3. Since we are multiplying by 3 over and over and over again, that would become 3 raised to some power. Okay? Now, here's what happens. Here's the reason why we have to do a to the n equals 2 times 3 to the n. Now, here's the thing. If I do 3 to the n, that means the very first one is going to be 6. Do we agree? So I can't do 3 to the n because the first time I do it, it won't work. Now, if I do 3 to the n minus 1, then when I plug in 1, I get 3 to the 1 minus 1 is 0, which is just 2. So the reason you got to drop it off by 1 is so that you can, the first term will be by itself before the 3 starts multiplying. Okay? We call this a geometric sequence.
And you got the 2 from the general chapter?
The 2 is always, the number in front is always the first number of this piece, if it's geometric. Because I'm about ready to do some that are not geometric. Okay. For example, if I gave you 1, 4, 9, 16, 25, 36, what would the general term of that be? Probably should pause this. I'm sorry for those of you watching at home. This one is n squared. I was going to use this to write. May not work too good. This is a to the n equals n squared. Okay. Each one of these is a perfect square. Now, what some people say is add 3, add 5, add 7, add 9, add 11, add 13, add 15, add 17. That works, but there's no good way to write that here. Okay? Let me ask you this. What if I did 1, -8, -27, -64, so forth and so on? What would that be? Question is it a to the n equals negative n cubed? Well, is that what you're thinking, or are you thinking this? Or does it even matter? Actually, in that case, it doesn't matter because an odd power to a negative number is going to be negative anyway. So if we did it that way, and here's the thing. What you have to do is, once you think you know what the general term is, just start plugging in some numbers. That's -1. And people go like this. Well, then that ain't going to work. Right? Because if I do 2, that's -8. 3 is -27. So forth and so on. All of those are going to be negative. If I put it in parentheses, all of those are going to be negative. So I know it's the cube. We've established that it's a cube. How do I get the alternating sign positive, negative, positive, negative, positive, negative? How do I get that to occur?
Times it by 1. Or negative 1.
Times it by negative 1?
Yeah. So the equation that you get before, and then you times it by negative 1.
So use negative 1 times negative n cubed. But if you do that, that's going to make them all positive. This is 1, this will be 8, 27, so it's not going to alternate.
Would you make the 3 negative?
The 3 the exponent? That's a great point. What if you make the 3 negative? What's the negative exponent going to do?
Make it the inverse.
It flips to the bottom, right? So sometimes we do want to do that, but not in this case. Diana, how do we make that alternating sign go negative?
I don't know, I would say that every even number would be negative.
Okay, so every even number is negative.
Yeah, but then I have to explain.
How about this? Would this work? Negative 1, n plus 1. Or n minus 1. We could use the n minus 1 too if we wanted to. Would that work? Would that do it? When n is 1, negative 1 to the 0 is 1. This is 1. When n is 2, negative 1, 2 minus 1. 2 minus 1 is 1, yes? So that's going to be a negative number. 2 cubed is 8. When n is 3, 3 minus 1 is 2. Negative 1 squared is positive 1. Does that make sense? So by putting the negative 1 to a power of n minus 1 or n plus 1, negative 1 to the n plus 1 and negative 1 to the n minus 1, those are all the same. Okay? Those are all the same. It'll make it even. It'll make it positive on the odd numbers. It'll make it negative on the even numbers. Does that make sense? So this notation becomes how you deal with that positive, negative deal. Okay. Let me pause here for station identification. I'm going to press pause. For those of you watching at home, you can press pause too, because when it comes back, it's going to pick it right back up. So the question was, does it matter whether you start off with negative 1, n plus 1, or n minus 1? And my response was, no, it does not matter. But if you start off with a negative, if this is a negative number, that's just going to become negative 1 to the n times n squared in this case. Because you want to lead with a negative number to start with. Right? So when n is 1, this is negative. When n is 2, this is positive. When n is 3, this is negative. When n is 4, it's positive. So it does matter whether it's negative 1 to the n or negative 1 to the n plus 1. That matters. What doesn't matter is whether you do negative 1 to the n minus 1. That does not matter. These two do not matter. Does that make sense? We good? Are you okay? Are you sure? Let's have some fun. I'm going to give you this one. what would the general term be for this? Let me press pause here. We called this recursive. Okay, in math circles, there's a concept known as recursive, which means we take the last value and we do something with it. Okay, so, and then I'm going to show you the general formula in a second, but I want to explain to you that what you're seeing here is n times a to the n minus 1. Where a1 is equal to 1, and a to the n is equal to n times a n minus 1. So what that means is when n is 2, it's 2 times whatever a1 was. When n is 3, it's 3 times whatever a2 was. When n is 4, it's 4 times whatever a to the third was. And so that's what we call a recursive way to write it. Okay? So writing things recursively is you write the first term down, and then you define each subsequent term as something that deals with the last. Okay? The general term for this, though, if you were looking to write this as an expression, the general term is actually n factorial. Okay? Just so you know, what is factorial? Factorial means you're going to do n times n minus 1 times n minus 2 times all the way down to 1. So like if I have to do 5 factorial, it's 5 factorial. 5, that's a factorial. It's 5 times 4 times 3 times 2 times 1. Okay? So when it counts up by 1, 2, 3, 4, 5, and it's multiplying like that, we call that factorial. Okay? And the bottom line is this. I don't know that most people would necessarily know that without being shown. Does that make sense? Like, that's not something that everybody just sits around and goes, oh, clearly. Okay? How many of you, just out of curiosity, senseless survey, how many of you have seen the factorial symbol before? All right, so a handful. All right. It's used in statistics, and it primarily means multiply going down the line. Get to 1 and then quit. I had a student who went to 0, and they didn't think it was at all strange that every factorial problem always ended up with 0. 8 factorial, 0. 20 factorial, 0. Well, why even have the factorial if every one of them is going to be 0? Small details. Okay. Any questions on that? Okay. So here's what we're going to do next. I'm going to give you the general term. A to the n equals 5n plus 4. I want you to find the first 5 terms, and then I want you to find the sum of the first 5 terms. So find them, and then let's find the sum. And we'll pause here.
Plus 9?
Huh?
Plus 9 or 4?
No, that's a 4 dot. Just my handwriting's not very good. All right. If you're at home, go ahead and pause and do it yourself as well. Once you get done, hit play. All right. Here, hold on. Let me set this up for people watching at home. Right now, there's Ariel, who's about ready to give us the answers here. So if it's not right, it's all Ariel's fault. Go ahead, Ariel.
I had 9, 14, 19, 24, and 29.
9, 14, 19, 24, and 29. Is that what you're saying to me? That's what you're going with. All right. Ariel, for 25,692 points, plus, wait, you don't even know what the hell the question is. For 25,692 points, plus guaranteed admittance into the Mathematical Hall of Fame. Just, you punch your ticket right now. What kind of sequence is that? I gave it a name. What did we call it?
Yeah, start with an O.
It started with an O. That's Oprah. And that is not, yeah, Oprah is the only name that starts with an O that anybody actually knows. It doesn't start with an O. Maybe that's the way you spell it. No. Actually, neither one of the terms start with an O or an S. But it does kind of sound like an O, maybe. Robert, what was it called? Arithmetic. Arithmetic. Yeah, that's on the board, actually. All right. So that's the first 5 terms. You get that by plugging in n equals 1, n equals 2, so forth and so on, all the way up to n equals 5. All right, so 1 times 5 is 5, plus 4 is 9. 2 times 5 is 10, plus 4 is 14. 5 times 3 is 15, plus 4 is 19, so forth and so on. Now, what's the sum of the first 5 terms? What did you get? How very aerial of you. You didn't even do it. You got done and then just sat there. Hey, Monica. I'm going to let you do this for us. I think Susan might be watching at home, so don't screw it up, okay? Monica, what's the sum of the first 5 terms? You got 95. Did you say you second that? But you didn't even do it. All right. It's 95. So here's what I want to show you. I want to show you how we write the sum of the first 5 terms. If a to the n is equal to, what did I say it was? 5n plus 4. The way I write the sum of the first 5 terms, it looks like this. It's this little sigma, 5n plus 4, n equals 1 to 5. That means add up the first 5 terms. Does that make sense? That means add up the first 5 terms. Now, in section, I think it's 11.1, they show you some formulas for how to sum up various values. Okay? And that's fine. I'm going to take a little bit of moment with the little bit of time we have left, and I want to show you how you would type this in. And then next time, after Thanksgiving, we're going to go over some of the formulas that you need to know and where they and help you figure out where they come from. But for the time being, let's go to our calculator. Now, I'm doing this live, and I'm not even sure I remember how to do it on the damn calculator. I ain't going to lie about that. But here's what I think we need to do. If I go to second link or list, second list, and I go over to math. So let me just show you again. Second list, and I go to math. Does everybody see the sum? Number 5? I'm going to take the sum of what? Well, it would be the sum of a sequence of numbers. That's under ops. Option number 5 is sequence. So it's the sum of a sequence of numbers. The sequence is 5x plus 4. I'm taking x as the variable. Maybe this is supposed to be in parentheses. Freaking shit, I don't remember. From 1 to 5. Okay. And I'm going to press enter, and I'm praying if I've done anything right in my life that it says 95. All right. I probably should really just like remember that stuff and come in like having studied it, but sorry. This is the sum of the sequence of numbers. Now, if I just said sequence x factorial for x from 1 to 5, that would just give me that sequence of numbers that we already saw. Does that make sense? That was the factorial that we did. 1, 2, 6, 24, 120. Okay? So sequence is under list and going to ops, and then sum is under list and going to math. Okay? So if you have a sequence of numbers and you want to add them up together quickly, that's the way you would do it. Sum, sequence, and that's, if you don't know the formulas, which we're going to talk about next time. There is a question. Yes, sir.
When I hit the sequence, my calculator gave me a different screen where I had to input variables and.
Oh, shit. All right. There should be the question is, some calculators don't do it the way mine does. At the top, it'll ask you for type in the expression, and it'll ask you what variable you're using. So type in x. It'll ask you for a starting point and an ending point probably.
Yeah.
And then it might ask you for a step. So type in 1, 5 for the starting and ending. For the step, just type in 1. And then once you get down to the bottom and hit calculate, whatever it is, it's going to post it'll post that formula into the sheet, into the calculator. Okay. So know how to use the calculator to find the sum. All right. We're going to go over infinite sums, which means it adds up forever. And we're going to go over arithmetic and geometric series on Monday when you come back from break. All right. Please start looking at definitely look through 11.1. And also, if you can, start looking at 11.2. It is Thanksgiving. I don't want you to spend the entire break doing math, but nothing says Thanksgiving like turkey and math. All right, so hopefully you can work in some problems. Have a great Thanksgiving, everyone. Be safe. Until next time, take care of yourself and each other.